Jai Hind everyone. I am Sheradha Jauhari, Assistant Professor IT Department in AKGEC Ghaziabad. Today we are going to discuss the topic of programming for problem solving, the subject which is in first year. The topic is algorithm and flowchart. So today we are going to discuss various topics such as computer, software, algorithm and flowchart. One by one, we are going to discuss this. As algorithm and flowchart are the basic building blocks of the programming. So first of all, we should know what are these. So first of all, we will start with the computer. So as we all know, computer is a programmable device. We only say that computer is an electronic device, but actually it is based on the concept of IPU, that is input-output processing. So any device which accepts input from the user and generates an output after processing the input values is known as computer. As we can see in the diagram that we are providing data as input to the system, and after processing with the help of instructions, we are getting the output, which is nothing but the information. So initially we are providing data, and what we are getting the information. So first of all, we should understand the terms data and information. What is data? Data is unprocessed facts and figures. Whatever we say which does not have any meaning or from which we cannot interpret anything is the data. For example, the price of crude oil is $80 per barrel. So what we are getting from it? We cannot interpret anything. We are just saying that price of oil is $80. But if I say the price of crude oil has risen from $70 to $80 per barrel, which this statement can be interpreted as the cost has been increased by $10. Means from this statement, I can interpret something. So this statement will become or will act as an information. So in a computer also, we provide data, and after processing, after interpreting that data, we generate some information as an output. Now, computer comprises of two things, that is software and hardware. So within this lecture, I am going to discuss the software part. So software is nothing but it is defined as the set of computer programs which includes all kind of logical instructions. We can categorize software as system software and application software. Within the diagram, we can see that we have hardware inside the system. After that, hardware part is covered with the system software, and upper layer is of the application software. So we have three different components, that is hardware, system software and application software. So system software. System software is nothing but it is a software which help us to read the hardware components, which help hardware of the computer to understand what user wants to perform on the system. So basically, system software provides an environment to the system so that user can perform multiple tasks. The various examples, or we can say types of system software, are the operating system, translators, linkers, loaders and BIOS. So all these softwares are providing or making a communication channel between hardware and the user. Next category of software comes the application software. Application softwares are the programs on which we user work upon. For example, we have word processor, spreadsheets, databases, media players, gaming applications, various software, ERPs. All these are the application software which are being programmed by we users only. So before starting the algorithm, we should know what are the software, why we need algorithm. So algorithms are basically needed to design such softwares because we cannot directly work upon these softwares. We cannot directly code for the software. So algorithm is the first step to design a software. So what an algorithm is? An algorithm is a step-by-step procedure to solve any problem. It is a sequence of computational steps that transform the input to the output, which means algorithm will give you the proper sequence of statements, or you can say the step-by-step solution to any problem. If you are generating a program for any problem, then first step for designing that program, for writing that program, is the algorithm, which is nothing but a step-by-step solution. What are the steps which you are going to define a solution for a given problem is your algorithm. So, it provides a step-by-step solution. The focus is on the step-by-step. The solution which you provide must be in a proper sequence, not in a random order. For example, if I want to add two numbers, so first step for this process is, first of all, I will take two values as input. Then only I can apply the formula of addition. So the sequence of addition of two numbers is, first take input of two numbers, and after that you just apply the formula sum is equals to a plus b. Then it will generate the output, or we can get a output that is the summation of two numbers. So when we are designing an algorithm, we must keep following points in the mind, or you can say these are the various characteristics or properties which an algorithm must have. First is the input. An algorithm required input from the user. Whatever algorithm you are writing must accept proper input from the user. Second characteristic is the output. An algorithm must give at least one output, because you are providing a solution with the help of an algorithm. So if you are providing a solution to a problem, then it must generate some result. That is why output is a necessary property of the algorithm. Next we have definiteness. Definiteness says each step must have unique, defined, preceding and succeeding steps. Means all the statements, all the lines which you are writing in an algorithm must be definite, must be unique, which are preceded and succeeded by different or unique steps. You should avoid the repeatedness of the statements. Your statements must be unique. Next is the finiteness. An algorithm should be terminated in finite number of steps. This must not be a case that your solution does not stop anywhere. It is generating output continuously. So your algorithm must have some termination condition, so that it must give result after particular condition and stop working after providing the output. And last characteristic of the algorithm is the effectiveness. Your algorithm must be effective enough so that it can be easily convertible to a program. Secondly, it must be solved using paper and pen. If you are writing an algorithm, it must work for smallest values also as well as largest data set also, so that you can check the effectiveness of the algorithm, that it can be solved easily with a paper and pen without having the utilization of large machines. That is the meaning of effectiveness. So in and all, we can say we have 5 characteristics of the algorithm, that is input, output, definiteness, finiteness and effectiveness. And if an algorithm possesses all these 5 properties or characteristics, that means we can say it is a good algorithm. Next comes the flowchart. Whatever we have written within the algorithm must be represented in a pictorial form with the help of flowchart. A flowchart uses multiple symbols to represent that data into a picture form. The various symbols which we are going to use are terminator symbol. That terminator symbol is used to show the termination or beginning of a process. Process symbol is used to represent an activity. Whatever calculations we are doing within the program or within the algorithm are being represented with a process symbol. Next, we have data. Data is being taken as input and is generated by the system as an output. So, whatever data which is taken as input and data which is being generated as output is represented using data symbol. Next, we have decision. Many a times we come to a situation when we have to decide among multiple paths. Which choice is right? We have to choose any one option. In that particular case, we use decision box. Last but not the least are the connector lines, which are used to connect multiple blocks, multiple symbols of the flowchart with one another. Secondly, they will also tell you the flow of data in which the data is flowing, from which part to which part data is transferring. So in the next slide, we are going to see the various symbols which are being used for these all kind of symbols. So the various flowchart symbols are, first one is the oval, which represents the start and end of the process. So whatever algorithm or whatever thing we are flowchart we are designing is being started with a oval symbol and must also terminate with the oval symbol. So we can say that this oval symbol is nothing but it is a terminator symbol which shows you the starting and end of the flowchart. Next we have the parallelogram. This parallelogram is used to represent the input taken by the user and output generated by the software or program written by the user. So every data which is being taken as input and whatever data is being generated as output is written within this parallelogram. Next, we have the rectangle. This rectangle represents the process part, that is the calculation. Whatever calculation we are implementing within the solution, within the algorithm is being written within the rectangle. So rectangle will possess all the calculation part step by step. Next we have the rhombus symbol, or you can say a diamond shaped box. This is nothing but used for the decision making statements. The situation where we have to decide among multiple paths, there we use the decision box, which is used to decide among multiple paths. Next we have arrows. Arrows will show the flow direction of the data, in which direction data is flowing or movement of the flow of data. Last but not the least is the circle, which is a connector symbol. When we have a situation that we have multiple lines are coming from a box and going into a single block, in that particular case, we can use the circle symbol to connect multiple lines into a single going box. So basically, circle will be used as a connector, which connect multiple lines and convert those multiple lines into a single line. Now, we should consider various examples so that we can more easily get to the concept of algorithm and flowchart. Before that, one term also comes, that is the pseudocode. There is a students very much get confused between the algorithm and the pseudocode. Algorithm and pseudocode are entirely different from each other, as algorithms are the basic steps which are used to solve any problem. They do not have any rule or any syntax. A user can write algorithm in his or her own language, in his or her own style. The only constraint with the algorithm is that the solution which is being provided must be in proper sequence, must be in proper order. But a pseudocode is an informal high-level description of a computer program. Means if I say from algorithm I have to design a program, in between I can design a pseudocode. So pseudocode is an informal way of writing a program which generally follows the syntax of the programming language in which we want to code the program. So for algorithm, there is no such rule to write these steps, but for pseudocode, it must follow the programming syntax. So we can say pseudocode uses the basic syntax of a normal programming language and is a human readable rather than machine readable. So I hope difference is clear between algorithm and pseudocode. Next, we will discuss the difference between algorithm and flowchart. Many a times this question comes in the exams that what is the difference between algorithm and flowchart. So an algorithm is nothing but it is a step-by-step procedure or solution to solve a problem. But in flowchart, we have a pictorial representation of the program. Flow of data, based upon the flow of data, in which data is flowing, the sequence of steps must be represented in pictorial form. So algorithm is written in basic English language and flowchart is a picture form of the data. Next, algorithm is very easy procedure which represent logics. But as compared to flowchart, logics are little bit difficult to draw as we have very limited number of symbols plus the flow of data. Students get very much confused while drawing the arrow lines, while deciding the conditions based upon which are being fitted in the decision box and the symbols, the similarity within the symbols, because flowchart uses proper symbols for taking input output and the processing of data. So it just creates a confusion between the parallelogram and the rectangle, where to use which symbol. So flowchart is little bit difficult as when compared with the algorithm. Next is the algorithms are very easy to modify as these algorithms are written within the language which user understands, which user speaks. So he or she can easily modify the algorithm. But to understand the picture is little bit difficult. So it is little bit difficult to modify the flowchart. Next, we have difference between the algorithm and pseudocode. As earlier discussed, an algorithm is a sequential steps of solution, whereas pseudocode is one of the method that can be used to represent an algorithm, not the problem, because whatever problem we have provided the solution within the algorithm only, and pseudocode is the next step for the algorithm towards programming. So first step is algorithm. After writing the algorithm, we can write the pseudocode, and after that we can easily write the program. Next, an algorithm can be written in natural language. As I told you earlier that there is no proper rule or syntax for writing an algorithm. So algorithm can be written in user language. Whatever language user understands, it can be written in that language. So it can be said that an algorithm can be written in natural language. But a pseudocode is written in the format which is near to the programming language. If I want to code a program in a C language, then the syntax which pseudocode will follow is the syntax of C language. So a programmer must write a pseudocode in a way that it is near to the programming format. Next, transforming an algorithm in programming code is little bit difficult, but pseudocode, it is easy. Why? Because algorithm is totally written in the natural language, a language which is understandable by the user. It does not follow any rule or syntax of the program. So it is little bit difficult to write a program directly from the algorithm. But if a user writes a pseudocode, then it is very much easy to convert a pseudocode to the programming language, because pseudocode is nothing but it is written within the format which is near to the programming language. So it is using the syntax of programming language. That is why pseudocode to program conversion is very much easy as compared to algorithm to program. So I hope difference is clear between algorithm and pseudocode and algorithm and flowchart. Next we move on to the examples so that we can easily get the concept of algorithm and flowchart. So here one by one I am going to discuss few examples of writing an algorithm as well as drawing its flowchart, so that you easily get the concept of both algorithm and flowchart. So first example I am taking here is the sum of two numbers. That how to write an algorithm for addition of two numbers. As we all know, for addition of two numbers, we need two variables A and B as an input, and after taking the input, the formula is applied, and after that result is being generated. So we know the process verbally. Now how to write an algorithm for this? So first step for the algorithm is start, which resembles that we are starting the solution. Now step 2 is input first number, say A. As we have to take two numbers as input, so first step will be to take input A. Next, input second number B. Next is the formula. As we have taken input A and B, now is the step for the formulation, that is implementation. Implementation part says sum is equals to A plus B, as we are adding two numbers. So a variable sum, it will take two variables addition with the help of plus operator. And last step will be display sum. As data is being stored within the sum variable, it must be displayed on the screen. And last is the stop. So as we can see, for addition of two numbers, the proper sequence is first taking the input, after taking input, implementation, that is formulation, and last is the output generation. So this algorithm is taking input, process is there, and this process is proper terminating after generating an output. So we can say this is an good algorithm. Now how to draw a flowchart for this particular algorithm? The very first symbol for flowchart is the oval symbol. So first is the oval symbol. In each and every symbol, we will write few lines or few words which will resemble your algorithm, or which will tell the user what this particular step is performing. So first oval is used for starting the process. So here we have written start. Next, within a parallelogram, take first variable as input. As we have discussed, for input and output, we use parallelogram. So first input here is A. So here we have used parallelogram. So first value is input value of A. Next, data flow goes to the input of second variable, that is B. So again draw a parallelogram, and within that you just write input value of B. The statements which you are writing within the symbols must be clear enough so that one can understand what you are about to perform in that particular step. Next, we have to implement the addition. And for implementation, what we have done, we have written sum is equals to A plus B. As this is the implementation part or the process for adding two numbers, it is being written within the rectangle. So rectangle is used for representing the process or implementation, or you can say the formulation part of the solution. And last step is the print sum. Whatever result we are storing, we are getting within the sum is being printed on the screen. So again, as this is the output, it must be written within the parallelogram. So for input and for output, we use parallelogram, and for process, we use rectangle. And last is the stop, which is written within the oval symbol. So start and stop are written within the ovals. Input and output are written within the parallelogram, and the process is written within the rectangle. So next we will go to the next algorithm, which is for calculating or finding area and perimeter of the rectangle. So for calculating area or perimeter of rectangle, what we need? We need length of rectangle, breadth of rectangle, area and parameters. These are the few variables which are being used during the solution. So first step is the start. Second, input length and breadth. Next, area is L into B. Perimeter is equals to 2 into L plus B. After that, display area and perimeter. Next, flowchart. Again, whatever input we have taken is written within the parallelogram. Process, two formulations are there, area calculation and perimeter. So these two are written within the rectangle, as these are process part. And last is the output, which is again written within the parallelogram. Okay. Next, again we take one example of swapping of two numbers. So for swapping of two numbers, what we require two numbers as input. Next, we are swapping two numbers with the help of third variable. So if I have two numbers A and B, how swapping is performed? First of all, I have to swap these numbers. So first of all, I will take a third number, third variable. In this, I will store data of first. After that, within first variable, I will store the data of second. And within the second variable, I will store the data of the new variable which is being taken by us. So in the same manner, these are the three steps which are being the process of the swapping of two numbers. So here temp is equals to num1, num1 is equals to num2, num2 is equals to temp. And after that, display the swapped data. This is the flowchart. We have taken input. Whatever input we have taken, we have just generated the output of same. Next, within the third block, that is rectangle, we have shown the process. And last, again, we have generated the output after processing the input data. So I hope the flowchart and algorithms are clear to you. We will continue with some other topic in the next lecture. Okay, this is the summary. What we have taken, that is Computer is a programmable device. What a data is unprocessed fact, and information is the processed and meaningful data. What is a software? Is a set of instructions which are being written in the form of computer program. Next, what is an algorithm? Is a step-by-step solution to the problem, and flowchart is the graphical representation of the process. These are the various references from where I have taken the data. I hope you understood the topic, algorithm and flowchart. We will continue with the next topic in the next lecture. Thank you.